In this video, I will be explaining the BCA 5th semester subject programming using ASP.NET as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 4 first important short question is: what is ASP.NET error handling? ASP.NET error handling means finding, controlling, and responding to errors that happen while a web application is running. Errors can occur for many reasons: wrong input, missing files, database issues, or programming mistakes. Instead of showing a confusing error message to the user, ASP.NET provides special techniques to handle these errors in a clean and user-friendly way. ASP.NET error handling is done using try, catch, finally blocks, custom error pages, page level, application level, and global error handlers. These help the developer catch errors, fix them, or show a helpful message. Example: if a user types letters instead of numbers in an age text box, the page may crash. But with proper error handling using try, catch, the application will show a friendly message like, "Please enter a valid number." This keeps the website working smoothly without breaking. In simple words, ASP.NET error handling acts like a safety net, catching mistakes and preventing the website from crashing, ensuring a smooth experience for users. Next important short question is: 2. Debug in ASP.NET. Debugging in ASP.NET means finding and fixing errors, bugs, in your web application. When a program does not work as expected, debugging helps you understand why it is happening and where the mistake is located. It is like checking each step of your code with a magnifying glass to catch problems. ASP.NET provides powerful debugging tools in Visual Studio, such as breakpoints, pause the program at a specific line. Watch window, check the value of variables. Step-by-step execution, run code line by line to see what happens. Example: suppose you calculate the total price in a shopping cart, but the answer is wrong. You can set a breakpoint at the calculation line and run the program step by step. This helps you find whether the mistake is in price, quantity, or the formula. In simple words, debugging is like solving a mystery. It helps you catch hidden errors, understand the flow of your program, and make sure everything works correctly before users use your website. Next important problem is: 3. Global Assembly Cache (GAC) in .NET. The Global Assembly Cache (GAC) is a special folder in the Windows system where shared .NET assemblies (DLL) files are stored. These assemblies can be used by multiple applications at the same time, so developers don't need to copy the same DLL into every project. This saves memory and avoids version conflicts. To place an assembly in the GAC, it must have a strong name, unique identity, which includes the name, version number, culture, and a public key. Example: imagine two ASP.NET applications on the same server use a library called mathfunctions.dll. Instead of keeping two separate copies, we put this DLL in the GAC. Now both applications can use the same shared DLL. If we update the DLL version, we only update it once in the GAC. In simple words, the GAC works like a central library of shared .NET files. Instead of keeping copies everywhere, applications borrow DLLs from one common place, making the system faster, cleaner, and more organized. Next important short question is: 4. Applications and server events in ASP.NET. In ASP.NET, application refers to the entire web application, not just a single page. ASP.NET provides special events that run automatically during the application's lifetime to manage important tasks. These events are handled in the global.asax file. Common application events. Application_start runs when the website starts for the first time. Application_end runs when the website stops. Session_start runs when a new user opens the website. Session_end runs when the user leaves. These events help developers manage things like caching, logging, counters, or initializing settings. Example: if you want to count how many users are currently visiting your site, you can increase a counter in session_start and decrease it in session_end. This gives you real-time visitor tracking. In simple words, application and server events act like automatic background helpers. They perform important tasks at the right time, when the site starts, ends, or when a user comes or goes, making the web application smarter and better organized. Next unit 5. Long questions. First important long question is error handling and .NET returns in ASP.NET. In ASP.NET, error handling is the process of finding, catching, and managing errors that occur while a web application is running. Errors can happen because of invalid input, missing files, database connection problems, or code mistakes. Proper error handling makes sure the website does not crash and users get friendly messages instead of confusing error screens. ASP.NET mainly uses try, catch, finally, page-level error handling, application-level error handling, and custom error pages to deal with errors. 1. Error handling using try, catch, finally. This is the most common method. Try code that may cause an error. Catch code that runs when an error occurs. Finally runs whether an error occurs or not. Example: try int marks is equal to convert dot to int32 txt marks dot text. Catch lblmessage.text is equal to please enter a valid number. If the user enters letters instead of numbers, the error is caught and a friendly message is shown. 2. Page-level error handling. ASP.NET pages can catch errors using the page_error event. When any error occurs on the page, this event is triggered automatically. Useful to handle page-specific errors in one place. 3. Application-level error handling. Defined in global.asax under application_error. This catches errors occurring across the entire website. It is useful for logging errors or redirecting users to a custom error page. .NET returns. .NET returns refers to how .NET handles the return of values and exceptions from methods. A method can return values using the return keyword. But when something goes wrong, instead of returning a value, .NET throws an exception. Therefore, .NET returns and error handling are connected. Normal situations return values. Problem situations return exceptions, errors. Example: if a function expects a number but receives text, .NET will return an exception, not a normal value. Easy way to remember. Try block is equal to risky area. Catch block is equal to safety net. Finally block is equal to cleanup. Page_error is equal to page's own doctor. Application_error is equal to hospital for the whole website. .NET return is equal to returns value normally, returns error when something goes wrong. In simple words, ASP.NET error handling and .NET returns help your application stay stable and user-friendly, even when unexpected mistakes happen. Next important long question is 2. Structured error handling in ASP.NET. Structured error handling in ASP.NET means handling errors in a clear, organized, and professional way using try, catch, finally blocks and built-in error events. This method helps developers catch problems early, show meaningful messages to users, and keep the website running smoothly without crashing. Instead of letting the application break suddenly, structured error handling controls what happens when something goes wrong. 1. Try, catch, finally, main technique. Try block contains code that might produce an error. Catch block runs only when an error occurs. You can catch general exceptions or specific ones like format exception, null reference exception, etc. Finally, block runs every time whether error occurs or not. Useful for cleanup activities like closing database connections. Example. Try int age is equal to convert dot to int32 txth.text. Catch format exception. lbl message.text is equal to please enter numbers only. Finally, cleanup code. If the user enters letters instead of numbers, the catch block displays a friendly message instead of crashing the page. 2. Page-level structured error handling. ASP.NET provides a page_error event inside each .asks page. If any error happens on that specific page and is not caught by try, catch, this event will run. Example. Protected void page_error, object sender, event args e. Exception x is equal to server.getLastError. Response.write, something went wrong on this page. 3. Application-level structured error handling. Found in global.asax using application_error. This handles errors for the whole application, very useful for logging and redirecting to custom error pages. Example. Protected void application_error. Server.transfer, errorpage.aspx. Benefits of structured error handling. Prevents application crashes. Gives meaningful messages to users. Makes debugging easier. Useful for logging errors. Ensures cleanup, closing connections, releasing resources. Easy way to remember. Try is equal to risky work area. Catch is equal to firefighter who immediately handles the problem. Finally is equal to cleaner who always finishes the job. Page_error is equal to handles errors inside a single page. Application_error is equal to handles errors for the whole website. Summary. Structured error handling makes ASP.NET applications safe, stable, and user-friendly by catching errors properly and responding to them in a controlled way. Next important long question is 3. Page-level error handling in ASP.NET. Page-level error handling in ASP.NET is a technique to catch and manage errors that occur only on a specific page. Instead of letting the entire website crash when a user makes a mistake, page-level error handling allows that page to handle its own errors, giving users friendly messages and keeping the rest of the website safe. This is done using the page_error event in the code behind of the ASP.NET page. How page-level error handling works. 1. When an error occurs on a page, the page_error event is triggered automatically. 2. Developers can use server.getLastError to get details about the exception. 3. You can then log the error, display a custom message, or redirect the user to a friendly error page. Example. Protected void page_error, object sender, event args e. Get the last error on the page. Exception X is equal to server.getLastError. Display a friendly message. lblmessage.text is equal to oops. Something went wrong on this page. Optionally log the error for developers. Log error X. Clear the error so it doesn't propagate further. Server.clearError. Scenario. Suppose a user enters letters in a numeric text box. Without error handling, the page crashes. With page_error, the error is caught, a friendly message is displayed, and the website continues to work normally. Advantages of page-level error handling. Prevents page crashes while other pages remain unaffected. Allows customized messages for users. Helps developers log errors for debugging. Works independently for each page, making it easier to maintain large applications. Easy way to remember. Think of page-level error handling like a fire extinguisher in every room. If a small fire starts in one room, the extinguisher handles it without affecting the rest of the house. Page_error is equal to local firefighter. Server.getLastError is equal to detective for error details. Server.clearError is equal to cleanup crew. Summary. Page-level error handling ensures robustness and user-friendliness. Each page handles its own errors, preventing crashes, showing friendly messages, and making debugging easier. It's perfect for individual pages in ASP.NET applications. Next important long question is 4. Application-level error handling in ASP.NET. Application-level error handling in ASP.NET is a technique to manage errors that occur anywhere in the entire web application, instead of handling them page by page. It is especially useful for large websites where errors can happen on multiple pages and you want a centralized way to catch, log, and respond to them. This is implemented in the global.asax file using the application_error event. How application-level error handling works. 1. When an unhandled error occurs anywhere in the application, application_error is automatically triggered. 2. Developers can access the error using server.getLastError. 3. You can then log the error, redirect the user to a custom error page, or notify the developer. 4. Finally, use server.clearError to prevent ASP.NET from showing the default error page. Example. Protected void application_error, object sender, event args e. Get the last unhandled exception. Exception X is equal to server.getLastError. Log the error, example function. Log error X. Redirect to a friendly error page. Response.redirect ~errorpage.asps. Clear the error so it doesn't propagate. Server.clearError. Scenario. If a database connection fails anywhere in the website, application-level error handling catches it. Instead of showing a scary server error, users are redirected to a friendly errorpage.aspx and developers can check the logs to fix the issue. Advantages of application-level error handling. Handles errors across the entire website, not just one page. Provides a central place for logging all errors. Improves user experience by showing friendly error messages. Reduces the need to repeat error handling code on every page. Easy way to remember. Think of application-level error handling like a security guard for the whole building. No matter which room, page, has a problem, the guard notices it, handles it, and informs the manager. Application_error is equal to building security. Server.getLastError is equal to detective. Server.clearError is equal to cleaning the mess. Summary. application-level error handling ensures robustness, reliability, and centralized control in ASP.NET applications. It keeps users safe from confusing errors, logs important information for developers, and manages all application errors from a single point, making your web application professional and stable. Next important long question is 5. Discuss managing application state using sessions and cookies. Managing application state using sessions and cookies in ASP.NET. In web applications, HTTP is stateless, which means the server does not remember anything about a user between requests. For example, if a user logs in, the server forgets them on the next page. To manage application state, ASP.NET provides sessions and cookies, which help remember user information across multiple pages. 1. Sessions. A session stores information on the server for each user. It is temporary and lasts until the user closes the browser or the session times out. Example. Store user name in session. Session username is equal to txtname.text. Retrieve username. lbl welcome.text is equal to welcome plus session username. Useful for storing sensitive data like login info. Works only while the session is active. Scenario. If a user logs in, their username is stored in the session. Every page can access it to show personalized content. 2. Cookies. A cookie stores small pieces of information on the user's browser. Cookies can be temporary, session cookies, or persistent, stored for days. Example. Create a cookie. HTTP cookie user cookie is equal to new HTTP cookie username. User cookie.value is equal to txtname.text. User cookie.expires is equal to datetime.now.adddays 5. Response.cookies.add user cookie. Read the cookie. String name is equal to request.cookies username.value. Useful for remembering user preferences or auto-login. Can persist even after the browser is closed. Difference between sessions and cookies. Feature session cookie. Stored on server browser. Lifetime until browser closed or timeout can persist days. Security safer, server side, less secure, client side. Storage limited per user, small data only. Easy way to remember. Session is equal to server's memory remembers user safely while online. Cookie is equal to user's notebook remembers user even after closing the browser. Summary. Managing application state with sessions and cookies allows ASP.NET applications to remember users, personalize pages, and maintain login and preferences. Sessions are secure and server-side, while cookies are client-side and can persist longer. Together, they make web applications more interactive and user-friendly, giving a smooth experience for users. Next important long question is 6. Describe HTTP handlers and their use in ASP.NET. HTTP handlers and their use in ASP.NET. In ASP.NET, HTTP handlers are special classes that process incoming web requests. They are the first point of contact for a request and determine how to respond. You can think of them as gatekeepers that handle specific types of requests before they reach a web page or web service. What is an HTTP handler? An HTTP handler implements the HTTP interface and contains a process request method. Every time a client, browser, requests a resource like .asps, .jpg, .txt, or .xml, an HTTP handler can process it. Why use HTTP handlers? 1. Custom processing. You can handle requests for specific file types or URLs. 2. Performance. HTTP handlers are lighter than web forms because they don't have page life cycles. 3. Dynamic content. Generate images, XML, or other responses on the fly. Example, creating a simple HTTP handler. Suppose you want to generate a dynamic text file. Using system. Using system.web. Public class text handler, it handler. Public void process request, HTTP context. Context.response.content type is equal to text plain. Context.response.write, hello, this is a dynamic text file. Public bool is reusable. Get, return false. Save it as texthandler.ashx and configure in web.config or use the .ash file directly. When the user requests texthandler.ashx, the handler sends the text dynamically. Use cases of HTTP handlers. Serving dynamic images, captcha images. Returning custom XML or JSON data. Processing file downloads. Handling special URLs without creating full web pages. Easy way to remember. Think of HTTP handlers as smart security guards at the entrance. They see every request before it enters the building web page. They decide what to do, whether to give a file, generate content, or redirect. Summary. HTTP handlers in ASP.NET are lightweight, fast, and flexible components that process incoming requests. They are ideal for dynamic content generation, custom responses, and high-performance tasks. By using HTTP handlers, developers can control exactly how certain requests are handled, making web applications more efficient and versatile.